Welcome to this episode of Let's Be Civil. Andy Herrmann joins me today on Let's Be Civil. Andy Herrmann is a bridge engineer and partner emeritus at Hardesty Hanover. Andy was the 2012 president of the American Society of Engineers and the 2017 president of the Structural Engineering Institute. He has been interviewed by several national news outlets and has spoken at congressional hearings. Okay, welcome everybody to our next episode of the Let's Be Civil podcast. And Andy is here with me today, and I've actually known Andy going on maybe 10 years, something like that now, from my time at Valparaiso University, where we first met and have been connected ever since. And he's been a great help in many respects, and actually has contributed to the start of the civil engineering program at Texas State in a couple of different ways. So I want to start out by saying thank you, Andy, for everything that you've done to date, and that I'm sure will come in the future. I'll pay it forward, I guess, and thank you in advance. I still will then too. So one of the reasons that Andy's been involved in this stuff is he's got a really varied, prestigious career. So why don't you give us some of the highlights? How did this all start for you? And now you're partner emeritus, as we were talking about a little bit ago. So why don't you give us some of the highlights?
Well, when I graduated from Valparaiso University with my civil engineering degree in 1973, it was a bad job market. I was sending out resumes, and I sent one out to Hardesty Hanover. It was a consulting engineering firm in New York City that works primarily on bridges, and they hired me as a structural detailer. And from 1973 to 40 plus years later, that's where I worked. I'm one of those rare people who never left their first job. I started as a structural detailer, and I ended up as a managing partner, and now I'm partner emeritus in my retired years. But I got to work on a lot of fixed and movable bridges. And the movable ones were the ones I found most exciting, because you worked with mechanical and electrical engineers, and you made everything fit and work. If the bridge opened and closed and didn't hit anything, you were a success.
So I have to ask, in all 40 years that you went to the same, did you actually work out of the same office, or did the office move during that time?
Yeah, when I first started, we were at 101 Park Avenue, right next to Grand Central Station in New York City. And then they took the building down, so we moved over to the Broadway area. One of the partners knew that this was an up-and-coming area, and we got into the old New York Times building. And that was where I worked for the rest of my career.
Okay.
And it was really great, because you could look out of our conference room and see MTV, ABC News. You could look up at you could see the ball drop on New Year's Eve. So
right.
A great location.
So I have to ask, what is your recollections of 9/11?
9/11, I was traveling. I was in Boston. I was at a hotel that my daughter worked at. And I was at a meeting or something, and she calls me first thing in the morning and says, "Dad, turn on the TV." So I turn on the TV, and you just can't believe it. You think it's fake.
Right.
But I just sat there and watched it.
Would you have been able to watch it from your office or from your floor where your offices were?
We probably would have seen the smoke.
Okay.
But we were up on 44th Street, and that was all the way down at the tip of Manhattan.
Okay.
But it obviously affected life for months and months and years afterwards.
Sure. And have you always lived in the same home? So has your commute been for that time more or less the same, or have you moved around?
Pretty much lived in Westchester County, which is the county north of the city, and took Metro North down along the Hudson into Grand Central and then to the office. So it's a very pleasant, because you get to ride next to the Hudson River and nice
Oh, okay.
commuter.
Okay. And now today, with you being, I mean, and so talking about some of the stuff, and you've got your ASCE. Sure, I can barely see the logo there. So there you go. That's another big part of your life, is being involved in ASCE and organizational stuff. So why don't you comment on that a little bit?
I was very fortunate to get involved in ASCE. Early on, I was part of some steel bridge committees, and then I got involved in the metropolitan section of ASCE. I became president of that. Then I ran for district director of ASCE nationally. And from there, I went on to the Board of Governors and of Governance, and then I ran for president. And I ran the best way you can for president, unopposed. No sweats. But being president and president-elect and past president of ASCE is quite the experience. I did a lot of traveling. I went to Europe. I went to China, New Zealand, Australia, Japan. It's fascinating. Engineers really respect the American Society of Civil Engineers. I got to testify before Congress 4 or 5 times on infrastructure and bridges and inspection of bridges. It was just a great experience. It was a great way to give back some of the experience you have just working, and try to tell politicians a little bit about what you do and what they could do to make things better.
And not only that, if memory serves me correctly, you have been on CNN.
I made 60 Minutes. I was the guy in the helicopter pointing out the bad bridges over Pittsburgh.
Right. Yep.
And the fun thing about it is that some of the comedy shows picked up on that report card stuff, and I got highlighted. And I think, what was it? John Oliver's last week. He made fun of us, but it was great because it got the message out.
Right. And what you're talking about is that ASCE does a report card on infrastructure, both nationally and then the state sections. I don't know if all of them do them, but they do
a good number, but about over 30. Yeah.
Right. On the status, and the report card is not very good. Right.
Yeah. I remember when Colbert picked up on the report card, and he was so excited because we went from a D to a D+.
Well, and this is where civil engineers, or prospective ones, can have a big impact, because
definitely
the status of the infrastructure today isn't that great, and we can do something to change that going forward.
Yeah, one of the things that civil engineers have to do is realize that they're usually experts in what they're doing, and the politicians don't know anything about it. So it's their opportunity to educate people. Yeah. And they have to be able to talk and write and do that.
Yeah. Were you, just to touch on the ASCE side a little for one other point here, were you involved in the student chapter at Valparaiso, or did you get involved with the organization more once you were at the professional level?
More at the professional level. Just starting out, one of the partners came to me when I was a young engineer and said, 2 of them actually. One said, "Hey, you should really be on the steel bridge committee for ASCE." So I joined. Another one came out and said, "Hey, you should get on the local steel organization in ASCE." And I said, well, one of the senior partners is telling me to do it. I should do it. So it was a great influence from them because they saw the importance of it and passed it on to me.
Right. So pick and I know we were talking earlier, and you're shifting computers, and so not everything is on your new computer system. But is there a particular project that you worked on over your career that stands out for one reason or another? Is there, or maybe what was the highlight for you? That might be the better way to ask that. What was the highlight for you, within your career in terms of the projects you worked on?
There were a lot of projects that I worked on over those 40 years. I go back to the first bascule I was actually made like project manager of, and it was amazing working from the drawings seeing the girders laid out in front of me, to actually watching the construction of it. And above all, when it was finished, standing there watching the leaves go up and come back down, and it didn't hit anything, and it really worked. So it's just coordinating with all the pieces. It was fantastic.
Was this one that you designed, or just that you were project manager for the construction?
I did a lot of the design as part of it also. One of the other bridges that was had a lot of interest was a bridge. It was a swing bridge from the tip of Manhattan to the Bronx. It was built in 1899. So it's an old truss swing bridge. And Amtrak wanted to use it for their new run up to Albany. So we got to rehab it structurally, mechanically, and electrically. And it was just amazing putting all the pieces together, because to put the machinery in, you had to put holes in steel. And you had to make sure that the holes in the steel weren't going in places where it was critical. So it was quite the jigsaw puzzle putting the whole thing back together.
And so swing bridge means that the bridge actually like rotates on an axis, a vertical axis, right? Like that, right? And then, go ahead.
Oh, one of the exciting things about that is that the contractor to rehabilitate the steel trusses took them away to New Jersey. So I was driving down the West Side Highway one day, and all of a sudden I see one of my trusses coming up on a bar. I think I almost broke an axle getting off the West Side Highway onto the curb to see it and take a picture of it.
And for those that are unfamiliar, truss bridge is the kind of bridge that looks like a series of triangles, more or less, that you either will drive through. A lot of people will have experience driving through, and the bridges surround you, or it's actually underneath you. So that's the style of that. So it's like a connects kind of if you built a bridge out of connects, it's a similar kind of thing. So you could take that apart, you could disassemble it, and then move it someplace. And
the other bridge project that I enjoyed was the first vertical lift bridge. That's one where the span moves up and down. It was out in Illinois, so I get to travel out to Illinois during the construction phase. And one of the things that I made myself do was walk across the top cord. Now this, sounds exciting, but the cord was 2 feet wide, and it did have a wire rail on one side, but I had to walk across it, and I was proud of myself for making it. So,
yeah, it would be a little scary.
Yeah.
So I was going to ask you this. The reason you have a movable bridge is you need something is too tall to go underneath the bridge. These are typically over water, or always over water?
It could be over water, or it's primarily over water.
Primarily over, so something needs to navigate underneath it. So they need or somehow get past it. So they have to move out of the way. So how do you decide swing versus, a lift?
Fast hill or vertical lift?
Yeah.
It depends a lot on the area that you are. Movable bridges usually are in more urban areas, because you can't get high enough on either side to get over the waterway. I mean, you'd have to be so steep to get up and over. The approaches would be way too long for a city. So that's a reason, because you don't have to make the bridge that high because you're opening it.
Right.
So the reason you'd pick one, there's varied reasons. Bascules, they open and they give you unlimited clearance, but since they're both cantilevers, it's limited and starts getting expensive the bigger they get. Swing bridges are great. You get 2 channels, but you also get an obstruction in the middle of the river. Vertical lift bridges are great. You just lift the whole thing up, usually longer spans, but they can be more expensive. So it gets down to economics and the waterway as to how you determine which one you're going to use.
Are they almost all steel structures then?
Predominantly steel.
Okay.
We have been called out in Seattle. They actually built a concrete swing span. It was in the news recently because it had cracks. But during the design phase, Partner and I were called out to do a peer review of the machinery and everything, lift this massive concrete off so it could rotate. But They're generally made out of steel.
Gotcha. So I was watching a show, the little analogy here, just the other day, and it actually it's quite fascinating. It's Cars That Built America. I don't know if you've ever come across this, but the History Channel has a series, The Men Who Built America, and they have one, Cars Who Built America, and they go back to the Henry Ford and all the original cars. And when you think about, there are people alive. I'm going to age you here. There are people alive that were around for a Model T. That today, but today could be driving around in a Tesla.
Yeah.
And so they could have experienced all of that technology. So over 40 years of a career doing these kind of bridges, you have to have witnessed quite a change of technology over that time, or has it been surprisingly little advancement in technology over that time?
The technology in terms of the structure really might be more high strength steels, better capacity bolts and welding, going into welding. The big changes have been in electrics, the electronic control of it, changing from the old wires to electronics and computer operation of the bridges. Also mechanical, used to be all gears, reducers. Now you're seeing a lot of hydraulics being used to move bridges. So the mechanical and electrical, we've seen a lot more change than the structural end of it.
But the structure, the early ones might have been, or ones you repair or renovate, would likely be rivets.
Yeah. You get around 1940 and less, 50 and less, they're mostly riveted.
Rivets. And then would they have gone from rivets to bolts or rivets to welds, or like is there a sequence, rivets, bolts, welds, rivets, weld, bolts, or how is that?
Well, rivets to bolts, to high strength bolts, to welding and bolts, and I think you're still going to see welding and bolts as a combination.
So smaller sections because of higher strength steel for the members, a different way that you're assembling the members, but the biggest change is actually in the operation of the movable parts of the bridge. Yeah.
The controlling systems and the power that you're using to operate it.
So how much of those things did you have to understand as a civil engineer? Was it just how did this get connected, and how much does it weigh, or did you actually need to understand how the hydraulic system works, or how the a gear system worked, or anything of that nature?
You have to start understanding how gears work. I was more into the mechanical in terms of gears and reducers than hydraulics. So you have to understand that. You work with a mechanical engineer, but he's got his needs, you have your needs from the structure side, and you got to work together. On the electronic operation of it, I got to the point where I could do a one-line diagram for the operation, just because you have to know the logic and the sequence of what's going on. But you need the electrical engineer to do all the deep details and everything like that. You got to have the overall understanding of how it works.
Right. It's not enough to just say, okay, there's an electrical engineer and they'll figure it all out and they'll just tell me what to do. You're probably going to, that's going to bring up issues. You're going to have, right.
Yeah, you got to work together. You're going to have to give him all the masses and weights so he can figure out how to supply enough power to operate it, and also his controls, depending on the mechanical, electrical. On movable bridges, you got to figure out the balance because you're trying to get the span between the counterweight and the span that's moving pretty close to equal in weight. Usually you want the span to be a little bit heavier so it stays down, doesn't bounce out into traffic. But you've got to know all these things. Span locks, you have to know how they operate and where they operate and how they connect to your bridge and what kind of forces they're going to put on your bridge so that you can design the structure for them.
And none of these things are covered in a university course. These are things that you have to you learn on the job, right?
Yes, yes, that's definitely, you learn on the job from a firm that has been doing well. Hardesty in Hanover is now over 130 years. So they've been doing it a long time. The founder of the firm actually designed the first modern vertical lift bridge in Chicago. So it's been a long time and a lot of on-the-job training for that.
And so you learned by going to them and asking them questions. So as you were working on bridges and you would come across something that you didn't know how to handle, they were your resource.
They would answer the questions. Sometimes they would do calculations and let me check them to see how they worked. I remember early on in my career, one of the partners gave me some mechanical connections to check. So I had to figure out what this all was and learn about mechanical operations and gears to do that.
So interesting. So one way that you learned to do the design work was to analyze someone else's designs.
Yes, yes.
Interesting.
Some of the first substructure I actually worked on was with another engineer. You checked his way of doing things, his calculations, and you learn how to do it yourself.
So in this time, when did you start utilizing computers in your 40-year career? When did that kind of start to come into play?
Let's see, we started getting big computers at the company to do calculations. We were sending like continuous girder spans out for getting runs and being able to analyze the output. And that was probably in the, I'd say, late 70s, 80s. And then we started getting some computers in the office in terms of the first IBMs.
Right.
Then the CAD came along and we had a lot of the separate systems. I think we had a Bosch and Lomb for a while before we started going back to the AutoCAD and the more popular ones that are today.
Right.
And now, I mean, it went from having 2 personal computers in the office to everybody having at least one. You know, some will have a desktop and some will have a laptop when they're working somewhere else.
So give me a sense of this. Back when you started, for you to design a bridge, basically from start to finish, how long, and maybe even if you just take an example, how long would that take when you started and you were doing everything by hand?
I don't think there's a difference in time.
Okay.
When we started, you know, it may take a year to design a bridge, but in the beginning, it's funny when you look at the history of bridge plans. You go back to the 20s and 30s, they had a complete vertical lift bridge on 8, maybe 10 drawings. That same project today would probably be 400 drawings. Because as we got the capability to do more computer design and drafting, they wanted more.
More, right.
More and more, where we tried to show only one connection once, now it's shown 4 times, and that also can lead to problems because It's got to be the same in those 4 locations. You got to make sure there's no error or discrepancies.
Right.
So designing, when I started, I bought a calculator when I first started. In fact, I bought a second professional slide rule when I first started work, which lasted about a year. But I bought a Heathkit calculator, which did 4 functions, and built it myself so I would have a calculator. So, you know, you try to keep up and advance, and then as you go through the whole thing. But in terms of time, it would probably take more time now because there's so much more the client and the contractor need to design the bridge.
Gotcha. So it's a different sort of schedule of work, but still ends up taking you the same amount of time. But you know, you can, I mean, people could appreciate that, because what do you do when you type things now, or if you do any kind of word processing? You never would rewrite a page because you had one little error, right? And now you'll redo the page 10 times and fix 10 errors, rather because
make it pretty.
Right. Well, speaking of making things pretty, I understand you're a handyman around the house.
Yeah.
So let's talk a little bit about your own skills here.
Well, I enjoy doing woodworking, and that sort of led into remodeling. Our second house we needed a larger kitchen. So off the kitchen, we had a deck. So I took part of that deck, got rid of it essentially, and we added a kitchen extension. So I hired a contractor to put the footing in, and then I did the woodworking and the roof and the windows and all that myself. And I found it quite enjoyable, and it's quite satisfying to build something, or actually see it. And being an engineer, I made shop drawings for the walls and everything.
Right.
So I built the whole thing, and we put up the whole addition for the kitchen. And I mean, you're in the driveway, you're building the walls. So I had a 12 by 8 foot wall, and you call up your friends, and they come over and they help you lift up the wall, carry it to the back, carry it to the top of the deck, and put it in place. And then I stood back and looked at it and realized that it shouldn't be this way, it should be this way. And you got to tell your friends that, wait a minute, we got to change this. But it was fun. It was fun.
And you have a little beer or something, beer and pizza after,
Oh, you got to.
Right.
But they were understanding, and I think they were kind of fascinated that they got to help do something like this. So after that house, we decided to build our house. So I became the GC. We hired an architect. We bought a piece of land, and I hired the footing contractor, got the concrete put in. I actually draw my own shop drawings for the steel and got a fabricator to make it and put it in place. Again, satisfying when it fits.
Right, right.
And hired since it was such a large, it was like 3,000 square feet. I had carpenters and roofers and everybody to do that. But it was just making sure everything fit together.
But I suspect you felt very comfortable in that role because you had done this kind of work professionally for 40 years. It was like, was there any part of this where you kind of were nervous?
Well, it's just basically project managing, and if you get the contractors put together, and you had to schedule them and make sure they're in the right time.
Right.
It's very satisfying, and you can actually go up and, I mean, the architect designed the steel beams for the whole house. And I look at it, and I think he had a different beam for every location. So I said, you realize that if we look for the heaviest beam, I mean, because it was a house, and make them all the same,
right?
It makes it easier for the fabricator because he only has to buy one type of steel. And he never had experienced that before.
Right.
Someone actually checking his work. At one point I came back and looked at his drawings and said, is there enough head clearance on this walkway to the back bedroom? So he had to look at it and then check it to make sure that there was enough head clearance.
Right,
so
right,
he never had anybody check his work before.
Right.
So I don't know if he'll ever work for an engineer again.
Right. Well, so I was going to ask you that. It's interesting that you'd mentioned this. We got a few minutes left here. My wife and I have built 3 homes in 3 different states. With 3 different, very different kind of construction methods. The second one was a guy, just a guy. He was a contractor developing a small neighborhood, and literally, he had some plans, but you would stand when he got the framing done in the middle of the home and look around, and he'd go, okay, should we change anything?
Wow.
Is everything good? And then you'd move on to the next step, to the one that we're living in now. It's like, we're not changing anything. I mean, so I didn't get along very well with the builder for the home that we're in now. So do you think that architect would work with you again, or did you rub him the wrong way?
No, it was good. He worked for an architectural firm, and he was doing some houses on his own. And this was probably the 2nd or 3rd house he had done.
Okay.
So we worked together on it.
Gotcha.
And he found things out, like in his future houses, he's going to design the roof first, right? Because it was so intricate with the way it was an L-shaped house and how it moved around that he kept modifying the roof to make it work.
Right.
So, I mean, I think he learned from this.
Yeah. And, I mean, I think it's safe to say that engineers in a lot of ways are know-it-alls. So,
really?
Yeah. And so one of the biggest struggles with the builder in this house was saying to them, like what you're suggesting. I mean, there were instances where I would make a comment and go, it would be easier, or the end product would be better if you considered, doing something different. And they just didn't want to hear about doing something different, which really kind of surprised me, because I said, but you could do this not just on this house, but all the other homes that you build, you could take advantage of this now. Whether or not they're doing that, I don't know. They could be.
Well,
but yeah, I don't think that they would want to work with me again.
the interesting thing about this house was I got to know the building inspector. And at one point I said, aren't you coming over and looking at the construction as it's progressing? And he says, yeah, I've come around. And then I saw your note on the wall to the carpenter, and I realized, you know what you're doing.
Yeah. So one last question for you. Now that you've worked with architects, because the work that you did as a bridge designer, you're basically the architect, right? You're the design of a bridge takes into consideration the aesthetics, but something like a home, that's a bit different, the skin of the building and the flow and all of that. So structural engineers, kind of pick on architects every now and again.
And it's deserved. It's deserved.
Yep, and it probably goes the other way too. But do you have a different feel since you've worked with them closely on a personal project? Would you look at architects differently having completed that project, or would you still poke at them?
That was a great architect. He worked well, and we worked well together. But this present house we're in, we were trying to figure out what to do with it. So we got a local architect to come in and give us some conceptual and a little bit further. And what I found was he just didn't want to listen to us. It was really frustrating. So eventually we parted ways.
Yeah.
And so it depends on the person and their approach to their profession.
Yeah. Well, and so that was our experience was like your prior one, is that they just didn't want to discuss any changes. So, our time is basically wrapped up here. But I greatly appreciate the conversation. It's a good one. That I'll be in touch with you about our program because you're on our board. But also just being able to speak to our students and doing that remotely is no big deal now. So,
yeah. I used to do that a lot with ASE. I used to visit a lot of campuses. So
Yep, excellent. Thank you so much for being on Let's Be Civil. I really appreciate you joining me today.
It's been fun. Thank you.
Yep, thanks.